Okay, today we're talking about truth tables, and in particular, we're looking at building truth tables from circuits. So here we've got our circuit. As we can see, our circuit is a combination of logic gates, and what we've got to do is we've got to build a truth table. So we've got to work out what the output will be here at X based on these three inputs A, B and C. Now the way to approach this is to be methodical. Okay, so what we can do is we can put extra letters in to help us solve this. So what we might do is we might say, well, we've got A coming into and we've got B coming into and. So we'll call this C. And so we'll put, we've already got C. Sorry, we'll call that D. Okay, so we'll put a D there. So we're going to work out D first. And then once we've worked out D, we can try and work out E, so we'll put an E here. And then once we've worked out D and E, well, we can try and combine those by working out F. So we'll have D, E, F. And then the result of D, E and F will go through the AND gate and will give us X. Okay, so we can we've got enough lines there. So that's what we can use the working space for. That's what the examiner has given you all of this space for. Okay, to work out the different stages. All right, so if we have a look at D, we've got A and B going through an AND gate. Now, if you remember your single truth table from an AND gate, the only time an AND gate is on is when both A and B are on. So when both A and B are on. So here A and B is 0. So that's going to be a 0. Again a 0. 0 and 1. 0, 0 and 1. A 0. 1 and 0. A 0. 1 and 0. 0. And here A and B is on. So that'll be a 1. A and B is on. So that'll be a 1. Okay, so perfect. So the only time that those D it'll be on is when A is on and B is on and A is on and B is on. So there's twice when that is the case. Okay, so now we'll try E. So E is going through an OR gate. So we're going to look at B and C. So we're going to look at these two columns, and we're looking and we're going to see what happens when they go through an OR gate. So an OR gate is one or the other or both is on. Okay, so if we start with B and C here. They're both off, so that'll be off. Here, one of them is on, so that'll be on. Here again, one of them is on, so that'll be on. Here, both of them are on, so that's fine, so that'll be on. Here, both of them are off, so that'll be off. Here, one of them is on again, so that'll be on. Here again, one of them is on. And here, both of them are on, so that'll be like that. Perfect. So that's through the OR gate. So now our job is we've got D here and E coming through into an OR gate. So we're going to combine these two columns, D and E, to form F. Alright, now it's through an OR gate, so we're just looking for whenever one of them is on. So here, nothing is on. Here, one of them is on, so we can put a 1. Here, one of them is on, so we can put a 1. Here, one is on. Here, both of them are off, so that'll be a 0. We can put, there's going to be a 1 there. A 1 there and a 1 there. Okay, just so you keep an eye on, make sure I'm not making any mistakes. And so that's F. So now we've got F goes into an AND gate, and that combines with C going into an AND gate. So what we're going to do here is we're going to take this column here, and we're going to combine that with this column here through an AND gate. So here we've got 0 and a 0, and that's going to be off. We've got 1 and 1, so that's going to be on. We've got a 0 and a 1, and that's going to be off. We've got a 1 and a 1, that's going to be on. We've got a 0 and a 0, so that's going to be off. We've got a 1 and a 1, so that's going to be on. We've got a 0 and a 1, that's going to be off. And we've got a 1 and a 1, which is going to be 1. Okay, so we've worked out the output from X. Okay, so we get 0, 1, 0, 1, 0, 1, 0, 1. Perfect. Now, at the bottom here, the question below is just what could replace the whole logic circuit? Well, If we look at the output from X, we've got 0, 1, 0, 1, 0, 1, 0, 1. And that actually matches C. Okay, so actually what we're saying is we could just replace, what could replace the whole logic circuit? Well, we could just replace the whole logic circuit with C.